So in this video we will learn the method calling, how method calling works, how do we call one method from another method, and what if we have to nest method calls. So a method, we can call a method from another method. In Java there is always one method which will be active, which is the main method, because that is the entry point of method. Even if we don't have any other method, even then if we run our program, the there will be one active method which is main, and any other code that we want to call, we call that code from main. So the execution starts from main method. Also in Java or in any language there is the concept of method stack. What is stack? Stack is basically a data structure, last in first out. It means that it simply, it is same as a stack of plates, for example. So let's say this is the stack item number 1, 2, 3 and 4. Now if you want to put an item, if you want to push an item onto the stack, then you will push that item on the top. So let's say this is the new item, it is on the top, this is the top of the stack. Now if you want to remove an item from the stack, then you cannot remove it, let's say 1 or 2 or 3, you have to do that on the top. So you can only remove 5. So let's say we remove 5. Now the top of the stack is 4. Again, if you want to push something, then here it goes. But if you want to remove something, let's say next item, then 4 will be the next item that will be popped or removed from the stack. So that is the concept of stack, and we will use this concept in the method calling. So let's say in the beginning the method stack is empty. Now we ran our program from the command line or from the IDE. So JVM will start executing the main method. So there is this entry of main in this stack which says that the currently main method is executing in is being executed by JVM, but it has not finished its execution. It is active, current active method is main. So we have this entry on the stack. Now let's say our program was something like this. Now the control reaches here and it checks that okay, there is a method call to M1. So what it will do, it will find the method declaration and it will call the method M1. So that will create another entry on the stack for M1, and the pointer, the new pointer is this, that M1 is currently being executed. That will partially or temporarily suspend the execution of main, because first it has to complete the execution of M1. M1 is not doing much, it is just printing the output. So we on the console we will get something like output colon the number being passed, so that is 10, output 10. Now the execution of M1 is complete, so that entry will be removed from the stack and the control reaches back to the main here, and because there is nothing else to execute, so main method completes its execution and the entry of the main is removed from the method stack, so the stack is again empty. Now let's say we have we change this method and we call another method sum, and we pass 4 comma 6 for example, and we may be just storing the return value in our temporary variable, and we may be printing this r for example. So let's see what happens now. Again we start running our program which creates the entry of main. This is the current active entry in the stack. Now it sees that we have a method call of M1, so it goes to M1 here and it creates an entry of M1 on the method stack. Then it prints the output on the console. M1 completes its execution, control reaches back at this point, so M1's entry is removed, so this is removed. So let's just remove it for now, and the control is back to M1 here. Now there is another method call to sum, and the passing we are passing two values. So the control reaches to sum method and it creates a new entry for sum here. It executes the logic written, basically n1 plus n2, and we are using the return keyword, so it returns the sum, in this case 10, and stores the output value in R. But the execution of sum is complete, so again this entry will be removed and control is back again to main method. It prints the output again, so on the console we will see something like 10 again, and it completes the execution of main method. So main entry is also removed from the method stack. As simple as that. Now another complicated scenario. Let's remove this thing. Let's clear some things and okay. So let's clean the slate and start from scratch. Now we have a call something like this. So we call multiply, we pass two values 1 comma 2, multiply again, and let's say 3 comma 2, sum m1. So this is our new logic inside main. It looks complicated, but bear with me. So the currently there is no active code or currently running code, so our stack is empty. Now let's figure it out. What exactly are we calling? So here we see that we are trying to call m1 method, which accepts a single argument. So this is the boundary of m1 call. It means whatever this is, it will basically return a single integer value. To do that, we see there is another nested method called sum, which means we are calling the sum method, and it accepts two arguments n1 and n2. It means within the boundary or the calling scope of sum, there must be two input values. The one is this and the other one is this, which is again a method called to multiply. It means that we don't have to pass a static value to call a method. We can actually call another method and pass the return value to another method. In this case, for the first argument, we are calling the multiply method and we are passing 1 and 2. So it means when the JVM calls multiply method, it will first multiply 1 and 2 and return the result 2, and that 2 on the runtime will be passed to sum method as first argument, and similarly 6 as second argument. So when 2 and 6 on the runtime are passed to sum method, it will basically do a summation, and the result of 8 will be passed to m1. And when JVM calls m1 with 8, on the output on the console we will see a single output of 8. So let's see it in action. So we start our method execution, which means we are calling the main method. So there is this entry of main on the stack. Now when the control reaches here, it checks that it has to call m1, but it doesn't have the absolute value. So it goes a little bit deeper and it checks that okay, we have to call the sum method first, but again it doesn't have the absolute value, so we cannot call sum directly. It goes a bit deeper and it checks that okay, this is something I have to call, multiply. So before calling sum or m1, first on the bottom, from the bottom it will call multiply first, which will create an entry of multiply on the stack, and the top current top is now multiply. So the method execution will start, this method execution will start, and it will return a value of 2. That 2 will be stored in a temporary variable, but it completes the execution of this entry, and this entry will be removed from the stack. So let's remove the entry from the stack, and the control reaches back to the main method. It again checks that in order to get this second argument to some method, it has to again execute another method, which in this case is multiply. So again the control goes to the multiply, and it creates another entry on the stack for the same method. The control comes here, it calculates the multiplication of 3 and 2. The output is 6, is stored in a temporary variable. The entry is removed from the stack, and the control reaches back to the main. So let's remove the entry. At this point on the method stack, there is a single entry which of main. It means main has not finished its execution yet. Now we have the absolute value of from these method calls 2 and 6. Now the runtime can call sum method. So it calls the sum method, which creates an entry on the method stack of sum. 2 and 6 are passed to sum. The JVM starts running the sum method, calculates the sum, and returns the out value, returns the return value, which is basically 8, back to the main method. So we have the output 8, which is being passed to M1, but it completes the method execution of sum. So this entry will be removed, and the current main again becomes the current top. So we have a single entry on the stack at this time, which means main has not finished its execution. It is still active. So it has to do something. The code is not completed yet. Now we have the output value of 8. We have the output value of 8, and now it sees that it has to call method M1. So it goes to M1 and adds an entry on the stack for M1. M1 has a simple job. It simply prints something on the console. So on the console we see the message which is output 8, and method execution of M1 complete. So the entry is removed from the stack, and the control is back with main method. Now there is nothing actually to execute, so that completes the method execution of main. So main has completed its execution, which means this entry is also removed. Now there is nothing else on the stack to execute. There is no top, there is no entry. That means our program is complete. So that's how method calling works in Java, or in fact in any other language, more or less. It's important that we understand the concept of method stack and how nested methods work in this case. For example, so if there is no absolute value, the runtime will call the method first, and after that method completes, the control will go back to the parent call or the parent method, whatever that is, and that's how the entries on the stack will be pushed and popped on runtime. So see you in the next lecture. Until then, bye bye.